Can you see the screen?
Yes, sir.
Can you see in the presentation mode? Is it visible? The full
No,
screen is visible, right? Can you hear? তোমরা শুনতে পাচ্ছ?
Yes, sir, we can hear, but I think the screen is frozen. Like we can only see the white over the
Oh
screen.
my God. What is happening? Now?
no change, sir.
Can you see it?
Yes, sir. Now it is visible.
It is visible. Actually, let me see one thing. Let me go to the presentation mode and see that the slides are changing or not. Now I'm on the presentation mode. The screen is visible.
Yes, sir.
Screens are changing.
Yes, sir.
Fine. So while I talked about the development of energy sector, mainly on the modernization of the sector, particularly in generation, transmission, distribution, all you know that a massive change has taken place due to digitization. Now this digitization, that means getting information of the through sensors and delivering the information either digitally or through various digital communication media has made our job much simpler, mainly getting of the information. Suppose you are doing something, you are running a motor in a factory, and you want to see that what quantum of electricity is flowing through motors and what is the motor's temperature. Now you are running the factory where the factory people are working, but you want to know the exact condition of how much products has been made and what is the condition of the machines. Now what you will do, you open your laptop or you open your smartphone. There is an app which is connected through the internet, and this app is showing that your say motor number so and so and so, they are taking so much of current, and their temperature is so, and your production has been done so much. So all the information you are getting with a remote access, and if you want, even you can have the control of motors. If you see that the temperature is going high but nobody is looking into the problem, and you are sensing that this rising temperature may cause problem of the motor, then you can also have a control on the motor and you can switch it off or you can reduce its load. All these facilities which can be remotely done has given a great advantage in the engineering discipline, in electrical area, not only in electrical area, in every aspect of engineering, in every aspects of manufacturing, and you can spread the facility to all possible aspects where this digitization has thoroughly changed the work styles. Even today, I'm taking the remote classes, that is also through this process of communication. So, this digitization has put our system, let us confine ourselves within the electrical discipline, has thoroughly changed the working periphery, working process of our electrical distribution system. And you can see that from your home to the industry to power generation, transmission, distribution system, in transportation, in business, everywhere, this digitization has changed the work processes and much facilitated the work atmosphere and the activities. Why I am talking about digitization only? Because when we talk about systems are becoming smart, it requires that a digital signal should come and go, one as information and the other as command. Information will show that this much current is coming to your home, and your instruction will be that if it goes beyond, say, 30 ampere, my electricity consumption will be more, so I won't allow to go it beyond 30 ampere. Let us take it as an example. It can be done on kilowatt basis, it can be done on overall energy basis, whatever be that. So if you put a smart meter in your house, and if you instruct the meter to behave like that, and if you are connected to a smart system where communication facilities are available between the command line and your meter, then you can merely do this thing. Even reversibly, if you have got a smart machine, a smartphone, and if you can control your electrical gadgets at a distance through internet, you can also do that. So these are the facilities which are coming and which has made our life easier, and these are coming as a load to the electric distribution system also. So whenever we are thinking that many things which are becoming in electrical distribution loads, like what are the loads possible, what are the energy guzzling materials or energy guzzling equipments which are taking more, rising more and more electrical demand, consider that all these servers, all these computers who are receiving data, who are sending data, all the remote terminals, RTUs, FRTUs, everything where you do place those, they are consuming energy very silently. You don't know, because these are not much the like industries where you see that fumes come out, smokes are coming out, there are chimneys, so there will be power consumption. So these servers and others, they don't have that much of industry like atmosphere. But even in an office or in a computer where much a large number of computers are there, servers are there, you see the loadings and the cooling requirement also be a huge load to the power distribution companies. So what we need the servers, we need the information, we need the communication for easiness of our industrial applications, information transference. At the same time, it is coming as a load and energy guzzling unit for the electrical division. So when yesterday I was talking about which are the loads coming in our system in future, although we intend to be much more efficient, but new loads are coming, which are creating, developing higher energy requirement in our system. So we started with 1208 energy consumption, but more and more digitization, more and more electronic applications do take place. More and more energy requirement will also be done, other than the industrial requirement, other than the agricultural requirement, other than the domestic requirement. So this is what I intend to tell. Now, yesterday I had also shown you this picture, that is the earlier grid and the present grid. In earlier grid, what we had in earlier grid, we knew that the power flow direction is from unidirectional, from generation point to the distribution point. Now it is bidirectional, or you can say multidirectional. because in between the normal power flow, that is from the generation point through transmission to the distribution, you have got distributed generation also, like solar, like wind, like storage, and they are giving support to you so that your primary fuel energy or fossilized fuel energy can be reduced. So you are putting those in your own for your own benefit, but at the same time it is causing a turmoil of current flow in the system. So you have to be very careful that from which source what type of current is coming. I mean, type means like it's all AC or it's all DC, whether you supply it in DC or you supply it in AC, but from which source it is coming, and you need to quantify that, and you need to maintain a balance of that. Otherwise, there will be, either overloading or some other problem will take place. Mostly overloading. Underloading doesn't create any problem, but overloading creates heat generation and it trips the main feeders. So you need to be very, very careful. At the same time, safety aspects has to be taken care of, and you need to monitor and quantify, because for energy consumption there is a method of billing. So for billing purpose, you need to monitor that what quantum of energy is being flown from which sources. So this is becoming the system becoming much more complicated than the earlier system. And such a complicated system you cannot log manually. So you have to have computerized control. You need to see from which point at every node what is the power coming, what is the power going out, and it should be monitored and see that the entire thing remains balanced. Electrical operations, everything should remain finally balanced unless there is any fault take place. So the balance is there, but you need to monitor that in your parlance real balance do take place, or there is a mismatch in load generation or on the current flow. So that is in the smart system, these are very efficiently monitored, and finally you get the entire picture, so that in case how it operates, I'm telling you, in a smart system. Suppose you see you have given an instruction that if the in a node, if the current exceeds a predetermined value, then it will give initially an annunciation, and finally it will allow to reduce the incoming load by some specific methods. What the methods can be? In a node, if you see the incomer becomes much highly loaded, it causes overloading because of the outgoings have started taking more load. Now there are two processes. You can reduce the outgoing load so that the incoming load gets reduced, or you can add up some generation at the outgoing point. It will also try to push some power in within that subsystem, and hence the incoming load will be reduced, because you are trying to balance out the incoming high flow of current by injecting some power at the other end. So both now you have the option, your system will have the option. It can try to control by reducing loads at other end simply by switching off some feeder which is not required, or by adding some generation at the other end, may be by switching on one storage, say battery, which can give some respite for the time being, and the incoming power will be reduced. Now it will not be done manually, because these are so automatic system. You cannot put a person who will monitor and control. So these are all automatic system. So it will be sensor based system, and ultimately the balance will take place as we have designed the system. Now if you allow some feeders to be switched off, then what will happen? The feeder which is not that essential, if it remains off for half an hour, that will not cause major problem. So the incoming situation, when it will be under control, that the overloading will go, and the feeder which has been shed, its capacity can be taken care of by the incoming feeder. Say it will statistically monitor, say half an hour, what may be the feeder loading. It will give us an instruction of switching on. You will calculate, you will instruct the process to switch on the feeder after, say, 10 minutes, 20 minutes, 30 minutes, depending on how its load reduces based on your statistical information, and the system will again be normal. So these are the facilities which are available in a smart system. There are multi facilities, hundreds of facilities. I'm just giving you 1-2 examples. So I think you have understood that how a smart system operates. Am I clear?
স্যার বলছি স্মার্ট গ্রিডের ক্ষেত্রে মানে ডাইরেক্টলি পাওয়ার প্ল্যান্ট থেকে কারেন্ট আসে না আলাদা কোনো গ্রিড থাকে আর আলাদা ভাবে?
ডাইরেক্ট পাওয়ার প্ল্যান্ট থেকে আসে। পাওয়ার প্ল্যান্ট থেকে যেটা আসে সেটা হচ্ছে গ্রিডের পাওয়ার। আর ভেতরে খুচরো খুচরো জায়গায় তোমাদের এই বিভিন্ন ধরনের জেনারেশন হয়, সোলার, উইন্ড, যাই থাকুক না কেন, সেগুলো লাগিয়ে দেওয়া হয়, বা স্টোরেজ। এবার মনে করো যে কোনো একটা জায়গায় তোমার মেন প্ল্যান্ট থেকে যে কারেন্টটা আসছে সেটা বেশি হয়ে গেছে, তখন তোমায় কি করতে হবে? আইদার কোনো ফিডারকে অফ করে সেটা কারেন্টটা কমাতে হবে, মেন ডিস্ট্রিবিউশন যেটা থেকে হচ্ছিল, অর্থাৎ মেন গ্রিড থেকে যেটা আসছিল, অথবা এই দিকে তোমার কোনো অ্যাডিশনাল জেনারেশন লাগাতে হবে, যে জেনারেশনটা ভেতরের লোডটাকে অ্যাপারেন্টলি কমিয়ে দেবে, অর্থাৎ গ্রিডের ইনপুট পাওয়ারটাকে কমিয়ে দেবে। এই জিনিসগুলো কিন্তু পুরোটাই অটোমেটেড ওয়েতে হয়। বোঝাতে পারলাম?
হ্যাঁ স্যার।
থ্যাংক ইউ। Now, conceptual model of smart grid ki smart grid is a large system of systems. System of systems কি? অনেকগুলো সিস্টেম নিয়ে স্মার্ট গ্রিডটাকে তৈরি করা হয়। তার মানে কি কি থাকবে? যে সেন্সর গুলো থাকবে, যে মিটার গুলো থাকবে, যে আরটিইউ গুলো থাকবে, যে কমিউনিকেশন চ্যানেল গুলো থাকবে, দে শুড বি কম্প্যাটিবল টু ইচ আদার। দ্যাট মিনস their operating protocol should match with each other. এটাকে that we call interoperability. Interoperability standards, so whatever standards are there, they should matching. Roadmap. Oof. Just a minute. Hello. हेलो, हाँ, आप कीजिए ना, आपको वेट करने के बारण कौन किया है? आप चाय वाय पीना है तो पी के आइए, लेकिन आपको टाइम है 8 घंटा, तो आप 8 घंटा वेट करके जाइए, ठीक है? अब मैं थोड़ा लेक्चर दे रहा हूं, थोड़ा 1 घंटा बाद आप फोन कीजिए। So the smart grids roadmap proposed by NIST, National Institute of Systems and Technologies, the American National Institute of Standards and Technology, the conceptual architecture for smart grid is composed of 7 big domains. What are those domains? Bulk generation, transmission, distribution, customer, operations, markets, and service providers. You just keep this thing in mind. I will ask no questions from smart grid, but as smart grid is becoming popular, I think if you have some idea on smart grid, that will help you. Now let us talk about generation. The generation is becoming bulk generation. There are two types of generations: bulk generations and small generations. What is bulk generation? Which is connected in grid. Now if you connect the bulk generation connect the bulk generation to the grid, now how you are connecting those? You are connecting those through transmission lines. So if you want to make your generation smart, then the transmission lines should also be smart operating. Now what is that? if there is any fluctuations in generation, if there is any requirement in generation which affects the ultimate consumer, suppose you are a retail consumer, but the impact of generation will finally come to you because it is generating power and you are taking power. Now this will be communicated to the transmission because the generated power will be released to the transmission lines. And finally, the transmission is connected to the distribution. So the distribution network should also be smart. That means it will have compatibility with the transmission system as the transmission system has compatibility with the generating system. The distribution system, ultimately what it does, it goes finally to the customer. Now the customer may be high value customers, they take bulk amount of current. A customer may be small value customer, they may be a customer like you, me, and say all like you, because who are small domestic customers. But everyone is a customer. So the customer's information should also be connected to the distribution system. And how the customer is connected? Because the customer is connected to you through meters. So if they do have a smart meter which gives its consumption pattern, its instantaneous voltage, current, all what the customer takes, if all these informations are available to the system, mother system, then it can monitor that which customer is taking what quantum of load, and this is connected to what feeder. So as a whole, you get synchronized and uniform from the generation to transmission to distribution to the customer end. And all these systems, like orchestra, do operate in a very synchronized manner, and this is controlled by the operations wing. So this information will also be connected to the operation wing, so that in case of any technical changes, the operation people or the operator can take the right decision at the right moment. Another 2 points I will tell. There are markets and service providers. And what is market? Electricity, so far I told, this is the technical movement. But thing is that now the technical movement has been converted into little bit of commercial, because there are multi-generators. Each and every generator's prices are different. The transmission are also becoming private. So the transmission tariffs are also, changing from, supplier to supplier, transmission line to line provider. So because of these commercials, the market from where you buy power and give it to the customer's tariff will also change. So these informations are also put in the smart grid operations. And ultimately the distribution connectivity, this is a system, but these are provided by the service providers. That means the people who are handling those. The service provider people should also have information from of the grid and of the entire system. So a smart grid comprises of all these parameters. Is it clear? বুঝতে পারলে কি বললাম?
Yes, sir.
Yes, sir.
And it requires a communication network. The communication network can be home area network. So you are in a building, all your meters are connected through HAN, that means home area network. And if you are in a housing estate, so large number of buildings, so these are connected through neighborhood area network. All these meters are connected. So from there, the data are being sent through internet and going to ultimately the consumer. It may not be connected to the internet, through optical fibers the data can go. So that is there. The field area network in a substation, suppose there are multi plants and these have individual fields. So these information again in a clustered form goes to the net or through optical fiber network, and all these informations connected from it will form a wide area network and goes to the control functions where the operators do take information. And these informations again gets channelized to the distribution control center, transmission control center, and ultimately to the generator. But all those datas are not required for all those operators. A transmission required the data relevant to the transmission, so these are channelized based on the demand requirement. Again, the generator do not require the basically customers requirement, because customers requirement are made by the service provider and the distribution companies and the distribution parameters. If similarly you do not require the information of a feeder, you are happy with only your meters information, so these in data are screened based on the requirement and feeding area, who needs what. Based on this, these are screened, right? Now I will tell a different subject, that is energy conservation and energy management. So these are basically, when we talk about smart grid, we understand that the grid is operating its best efficiency. Because to keep the frequency at a certain level, to keep the demand, and to make the operations optimal, that grid operations will be managed in that fashion. And when you are in a smart grid, the grid takes care of the best possible services to you, because there is no human intervention. The computer has been given the best logic so that this will happen. The optimal prices will be loaded to you. The cheapest power will be procured at the beginning, and the machines will try to do their maximum possible at the optimal cost. So these optimizations do take place in smart operation. But what we cannot do, that is when it goes to the customer end, the customer on which we do not have any control. You don't know a factory who is running a very old machine, but he is happy that whatever produces it make, these are all sold in the market. But unfortunately, in electrical parlance, the factory is making huge losses of electrical energy. That means they are making huge wastage of energy. And such huge wastage, if we consider that still our energy contains 80% thermal, so they are creating unnecessary carbon dioxide because of fossil fuel burning, because fossil fuel burning could have been saved if if the industry was more efficient. I'm giving you an example that you see what are the losses. In a generating station, suppose in a thermal generating station, the generation efficiency is usually 92%. That means 8% is auxiliary loss. What is auxiliary loss? If you run a generating plant, you need to spend some amount of energy to run the auxiliary plants like IDFD fan, like the water, to run the water system, clarified water, the main intake power. So there are so many, the boiler feed pump, all this equipment should run. So it is 8%. You can save it to more, but standard I have taken 8%. Now the transmission power. You are transmitting bulk power from one point to another. Suppose your plant is at say Bandel or Shagaddi, you are transferring this power to Kolkata. So you are running it for Shagaddi, you are running it say 200 kilometers, and there are many substations in between. So as a whole, the transmission loss is 5%. So the transmission efficiency is 95% and transmission loss, I presumed, is 5%. It is normally 3 to 5%. Sub-transmission efficiency, what is sub-transmission efficiency? You are now you are reducing the voltage, say from 220 kV to 33 kV. So big transformers are there, and you know that losses in transmission lines is I square R. As you reduce the voltage, the current quantum goes up, the resistance is high, so the I square R loss will be more. So the efficiency is 90%. It is a reasonably good efficiency. Now the distribution efficiency, the government has allowed that you can make up to 15%. Although there are scopes of improvement. Obviously, there are scopes of improvement, but I am considering the standard one, so 0.85. And lastly, I presume that when it reaches a distribution, when it reaches a customer who is a industry, its efficiency level is 75%. That is pretty good, because if you inspect an industry and if you see their industrial efficiency, it is even much less than 75%. But of all these parameters, so overall efficiency is 50%. What it transpires that if you produce 1 unit of electricity, ultimately it reaches to the customer with 0.5 of that. That means if you produce 2 units, the customer basically is enjoying 1 unit. 1 unit is gone in the entire process. Now, what will be our objective? If you can reduce these losses to the extent possible, then the customer, if we can totally the entire product, if we can make it say 0.65, then the customer will get somewhat more energy. Not only somewhat more energy the customer will get, we will be able to reduce the proportionate carbon generation. So that is the crux thing in our sustainability, how we can improve efficiency so that we can reduce CO2 generation. At the same time, we can also try to reduce the thermal generation by injecting more renewable in our system. That is the government is trying right now. So as you see, gradually our renewable percentage is increasing. The ultimate objective is that how we can offset carbon dioxide CO2 generation, right? So now there another term you might have come across, that is DSM, called demand side management. That is managing the thing from the customer side, who are on the demand area. Now, it is very difficult that the distribution people will go beyond their area and advise the customers. But all you know that the demand generators are the customers. Now it is the customers' responsibility also. They are buying electricity, and if they can reduce electricity consumption by using more efficient equipment, by using more improved processes, they can reduce their electricity bill at least. So that will in turn give impact to lesser drawal of electricity, lesser drawal of, reducing their electricity bill, at the same time less production of carbon dioxide gases. So that is how it can help the sustainability with reducing the emission of greenhouse gases. So this is a cogeneration. Cogeneration means when you are generating, you are releasing some amount of heat energy to the system. Now, if you can utilize that heat energy in thermal generation, we always utilize that heat energy by heating the incoming water, right, through various heat exchangers. You know that, I am not detailing. And there are solar, that is rooftop solar plants. We are using PV, which will ultimately get into our system, domestic system. This solar portion will partly, give energy to some of our domestic systems, and rest we will buy from the grid. If our solar energy generation is more, perhaps we will not buy anything from the grid. On the contrary, we will push some power to the grid so that we will support that time through solar energy. That will reduce some amount of thermal generation. That is also helping the grid and helping sustainability. So the rooftop is becoming popular, but there are also, a flip side of that. Now we are using net metering, but the government is not, or the many companies are not trying to use net metering, because here the power you take, the tariff rate and what power solar will generate, it both are of the same tariff rate. So the government or the companies are losing in that fashion. So there are some tariff change possibilities are there. That is called gross metering. Whatever you produce, that will be sold to the grid with a different billing, that is 3 rupees a unit. And whatever power you purchase from the grid, that will be treated separately at a different rate. Suppose the distribution rate is 8 rupees a unit. So you buy power 8 rupees a unit for your entire consumption. And if you produce, say, if your entire monthly consumption is, say, 400 unit, you buy 400 unit at the rate of 8 rupees a unit. And if you produce 100 unit solar through your solar rooftop, then you will get a price of 3 rupees for this 100 units. So as a whole, 800, 400 into 8, that is whatever is the price, say 320, and 100 into 3200, and say 100 into 3, that is 300 rupees you are getting from solar. So these will be subtracted, and finally you have to pay the bill to the government. So these are the net metering, gross metering differences. But ultimately, whatever you produce, that will help to reduce the thermal generation, and this will also help to in the process of sustainability. So this is the conventional electricity bill, what I told, that is depicted here. So I'm not stressing on that. There are other points which are coming in the system, that is our electricity, what we, in the distribution process, what it goes to the customer, do have some quality issues, because with many non-linear loads, like the loads which are having diodes, which are having transistors, they break the frequency cycle into different shapes, which create, if you go it, break it through Fourier analysis, you will find that there are odd number of harmonics do generate. The even harmonics do get cancelled, odd harmonics only remain in the system. So the harmonics will create, various problems in the entire network. It creates unnecessary heating of the laminations because of this hysteresis and eddy. This creates unnecessary losses. Burns out the capacitors, and creates various noises in the system. So these are also needs to be eliminated from the system, and it also affects the efficiency. So these are the issues which are coming up today with the smart operation, with more electronic applications, with more new gadgets. These are the problems which is developing in the city areas. So this is also a menace. We need to control it, and I think many of our students in future will also be engaged in these areas, where they will try to find out solutions how it can be controlled. There are solutions also. The harmonic filters are there. There are active filters. They are costly. So we need to make in future a cheap version of that, so that people can utilize it in a more proficient way. So our now journey towards sustainability. So the points what we have at the end of the presentation, that electricity for all we have achieved, energy at affordable cost, the everyone is trying yet to achieve, but the prices are will reduce with more addition of more addition of renewables. Compliance with INDC commitment, I told you that INDC is intended nationally determined contributions. What it is right now, moving towards 500 gigawatt thermal, moving towards 500 gigawatt generation, renewable generation by 2030, and 40%, 50% renewable again by 2030. Every year, reducing 1 trillion ton of carbon dioxide every at the end of 2030. So these are our targets. Green energy and clean air is our target, where we need to give more stress on environment management, availability of potable water, which is becoming a scarce element right now. In the chapters of environment management, you see that how government is taking actions and how you people will take actions, making the Swachh Bharat program successful. And our target is net zero by 2070, that ultimately whatever carbon dioxide will produce, that will be nullified with the production of oxygen and absorption of that carbon dioxide in the system. This is a very, very difficult target, but we need to achieve that. Anyway, the last presentation is closed. Now I will start a new presentations on sustainability. I will not take you more. I'll take only 15-20 minutes for that presentation. Are you okay with me?
Yes, sir.
আচ্ছা, তোমরা কোনো কোয়েশ্চেন করছো না? মানে আমি ঠিকঠাক তোমাদের লাগছে তো? ভালো বুঝতে পারছো তো?
হ্যাঁ স্যার।
ঠিক আছে, দাঁড়াও এই প্রেজেন্টেশনটা বন্ধ করি, করে আবার নতুন প্রেজেন্টেশন খুলি। দেখতে পাচ্ছ? Is it visible?
Yes, sir.
Yes.
What is the question first written there? What is sustainability? Is that?
Yes, sir.
Now, what is sustainability? Sustainability consists of fulfilling the needs of current generations without compromising the need of future generations, while ensuring a balance between economic growth, environmental care, and social well-being. Whether the meaning is clear? Sustainability বলতে কি বোঝো? Sustainability বলতে বুঝি আমরা the fulfilling need of current generations, অর্থাৎ কারেন্ট জেনারেশনে যা নিড আছে সেটা মিট করব, এমন ভাবে করব যাতে ভবিষ্যতের লোকেরা আমাকে গালি না দেয় যে ওরা তো সবই খেয়ে ফেলেছে, আমাদের আর কিচ্ছু নেই, without compromising the needs of future generations, while ensuring a balance between, এবং এটা করছি কেন, ব্যালেন্স between economic growth, environmental care, and social well-being, so that the objective is that the world which is having, which is being right now having flora, fauna, and the most intelligent animal, the human being who are in the society, But the most intelligent people are the most obnoxious people, because they are with their for their greed are exploiting the world in such a way that they are also they with their own greed, they are, you know, advancing their end point very fast. So what we need to definitely we need to live, but we will live, not only we people, but our future generation will also live. So we must not be mercilessly consuming all the natural resources. We should be very optimal in using natural resources, at the same time try to behave very rationally, so that we will keep these resources for usage for the future generations. Now, what is sustainable development? যেটা বললাম প্রায় সেটাই, meeting the need of the present generation without compromising the ability of future generations to meet their own need. Any two of the definitions on sustainability will do, but the definition number one is better explained. Sustainability is also the possibility that human and other forms of life on earth will flourish forever. Very small definition, enough for all, forever. But if the question comes, you will try to answer the first one. Can you see the second page?
Yes, sir.
What is sustainable? What is sustainable development? Development that meets the need of the present without compromising the ability of future generation to meet their own needs. These two pages are similar, but still I am repeating. Why? The reason is that I want to impregnate the statement into your brain, so that you should not forget the definition of sustainability. In other words, sustainable development is the criteria for achieving social and economic progress in ways that will not exhaust the art's finite resources and not exploit or impoverish one grouping of people for the enrichment of other. In a very simple way, you see, it is talking about equitable distribution of nature's wealth amongst people without hoarding it. Unfortunately, human nature is just the difference. Anyway, now what are the 2030 sustainable development goals? Now, এবার sustainability এই কনসেপ্টটা কবে থেকে এলো? It is a recent one. You know that till 2000, people were not bothered that what will happen to them in future. Some of the scientists, some of the environmentalists had that concern, but common people were far off from the thought. But in 2015, before that, there is a conference of parties named as COP. They used to talk about the environment of the world, and they were noticing that the climate is not remaining same as it was earlier. The winter becoming more stringent winters, more tough winters, and the summer is also becoming hotter. The rainy seasons getting shifted. Many natural calamities are taking place through storms, blizzards, and others. And the water level, the dry areas are increasing. The polar ice are depleting. So such things were being observed, and these were being observed from NASA vision points. They could see that there are some changes which is happening in the earth. Now the very strong query came that why it is happening. and it has been identified that the globe is becoming, hotter and hotter. And in 2015, in Paris, the conference of parties were assembled and a protocol was signed. What is the Paris Protocol? It says that before industry started, that is in 17th century, the global temperature was something around average temperature something around 23 degrees centigrade. But now onward, the temperature has increased. In fact, I cannot tell you exactly what the temperature was, but it has been identified that from pre-industrial level till then, we are allowing the globe, allowing the world to increase its temperature. And if the temperature increases beyond 1.5 degree and crosses 2 degrees centigrade, there is a great possibility of natural calamities. Till date, we have crossed 1.1 degrees centigrade. So we have very small time left. That's why the the realization, it's a late realization, it has come. Even then, after 2015 to 2023, we have spoken much but done little. If we cannot tighten our belt, young boys are going to see a world going to see a different world. That is our concern, and that should be your concern also. Now, what they say is on September 25, 2015, after 3 years of debate and negotiations, all 193 member nations of the UN, including the United States, voted unanimously to adopt these global sustainable development goals. তো এই সময় 17টা সাস্টেনেবল ডেভেলপমেন্ট গোলকে আইডেন্টিফাই করা হয়েছিল, যেটা শুধু যে সাস্টেনেবিলিটি অন এনার্জি তা নয়. There are many goals. I will give you the presentation in say by tomorrow or day after tomorrow. I will give you the presentation. You will see what are the 17 goals. I will today briefly discuss. And it is basically for the betterment of human being. But again, it's like a syndrome of, সোনার পাথর বাটি টাইপের, যেটা ঘটে না. We are in one phase, we are talking about the sustainability of human being, and on the other hand, we are, a mere spectator of Russia-Ukraine war since last 1 year. So this dichotomy in the world, dichotomy in politics is there. But if we do not enter in politics, let us see that what are the goals and how we can also involve ourselves in this goal. Who wrote the 2030 agenda and the 17 goals? Representatives from all 193 member nations of the United Nations and hundreds of non-government organizations, NGOs, and civil society groups representing indigenous people, small farmers, working people, environmental movement people, scientists, social workers, minorities, women group, and other stakeholders over a 3-year period of time. They identified these 17 goals. There are no poverty, naturally. In the world, billions of people live under poverty. In India too, you can see the India is, that there are different Indians. We belong to the middle class. There are stinkingly rich people, and there are really poor people who live in shanties and who cannot meet their both ends and cannot get food for the handful of food in their daily lives. So poverty is there. Zero hunger. Hunger is there. Good health and well-being, it is a mandatory requirement. Quality education, it is also important, because if people do not get education, they are misled with lot of superstitions, wrong beliefs. They cannot take any decision. The decision what they will take may not be justified decision, because they don't know, they don't have education. Gender equality in India, you see, the girls are treated differently, boys are treated differently in many states. Only you are seeing perhaps a section of the society, they are educated, they are middle economic level. I usually consider the students are coming from middle economic level, but there are really difference in boys and girls, so gender equality is required. Clean water and sanitation in India, the example is Swachh Bharat. There are in many villages there are no toilets, so these never allow the water and sanitation facilities, clean water and sanitation facilities. Affordable and clean energy, where our study gets concerned. The affordable and clean energy. Clean energy means the energy which is green, right? Free of pollution, free of carbon. So the affordable and clean energy we don't have. Decent work and economic growth, that is really our dream. Industry, innovation and infrastructure, again it is our dream. Reduced inequalities. India is a country of many inequalities, so it is also our dream to reduce inequalities. Sustainable cities and communities, the smart city. We talk about smart grid. Now we talk about smart cities, where you will get all benefits, and it should be a clean and green area where you can take breathing. You can breathe freely. Responsible consumption and production. This is also, there will be no wastage, and there will be no shortcoming also. That is responsible production and consumption. Climate action, which is also partly under our area. The sustainable cities and communities also partly under area. Life below water. In the process of pollution, we are killing the aquatic animals, so we should be concerned about life below waters. Life on the land, that is the flora fauna. With the process of urbanization and random city development, construction activities, where the animals will go. So life on land is at stake right now. Peace, justice and strong institutions. So the requirement of legal system, proper justice are becoming are getting difficult in many countries, even in our country. So this peace, justice should prevail, and partnership for the goals. The 17th one is that all countries should work together to achieve this. Now there are pages which will identify this, so you can surely go through those 17 SDGs and try to point out whatever, as I said, that which are the goals related to the goal number 7, what is clean and green energy. So basically, this is a requirement for sustainability. I am stopping here. In future, I will meet you again. I will tell you the date. Seeing my schedule, I'll inform Gopal. Sometime in Wednesday, I'm telling you in advance. Holi kabe?
8th of March.
8th of March. Obviously not on the day of Holi. That is in Tuesday, I think. Right? So 9th, is it okay with you? Let me take your option. 9th is okay with you?
স্যার মঙ্গল বুধবার হলি না?
মঙ্গল বুধ দুদিনই হোলি। আচ্ছা, তাহলে আমরা থার্সডে ভাবতে পারি? ঠিক আছে, আমি বলে দেবো। Is there Gopal?
Yes, sir.
Gopal, I will give you the date.
Okay, sir.
In all probability, Thursday. Keep you mentally prepared. I will write. Right?
Okay, sir. Okay, sir.
Okay.
Okay, sir.
I'm leaving. Right?
Okay, sir.
স্যার বলছি এটার কোনো
On Thursday evening time only, na sir?